Hello everyone, it is Mike Levin getting ready for another quick streaming session. It's weird to be doing Control-Alt-W for my Twitch studio as my first step in a getting started session. I've actually been working for quite a while, but it was on another project and I'm only getting to my big project now. So I did a system restart just because I like to show a fresh start at the beginning of a session. Alt-Tab is not what I want, it's Windows-Tab. So because I did Control-Alt-W for Twitch Studio at the beginning, it put it on Desktop 1, which is never what I really want. I want it all the way over here on Windows 7, and then Control Windows left key, go all the way back to Screen 1. Demonstrate that with the Windows tab. I want Screen 1. And from there, I do Control-Alt-T for my Windows text editor, or terminal, really. Welcome to Lundervant. So that's kind of the name of a book concept I have. I might launch a website. I've registered the domain, but of course, it's a play on Wonderland, but if you Google up what Lunder and Fond are, you'll see I'm making a very, Statler and Waldorf criticism or satire, flinging poo with a wand. So the idea is it's a tech commentary thing. There's been almost nothing love-worthy in tech since the Amiga, but I'm happy to say that my second keyboard shortcut, or in this case third since I'm twitching these days, is Control-Alt-J. I just double-click the icon, but Control-Alt-J for me fires up Jupyter Notebook, full-screen console. These consoles are important concepts. We'll be seeing that real soon because it factors into my real everyday workflow stuff. And Jupyter Notebook launches Chrome, which drops me into my sort of natural home location. It's a Jupyter Notebook decision. It drops me into my Windows home, which from there I'm able to drop into my GitHub directory, which is always in my natural home location, so it's really easy to navigate around. We've been working on the Python SEO project, and when last we left off, it was the end of this epic hour-and-a-half session where I got basic SERPs working. And so I figure I will do as much short and abbreviated this time as I was long and drawn out the previous time. So first we bring up the notebook. This probably won't be as long in the future on future tabs I bring up, because as you'll recall, every Jupyter Notebook tab has a Python virtual machine or a Python kernel associated with it. So it's running in its own sandbox, isolated location, just the way JavaScript does in Chrome itself. So it's sort of a play on the architecture that JavaScript made up. I'm importing the regular expressions for those who have been following along. This is to get regular expression matching. And the requests object is to get an HTTP API for humans. And then from itertools import cycle is simply to cycle through user agents. So those are just some comments to remind you about what the libraries are. Now, Pipulate is a really mixed bag, and this code below there is really just doing import Pipulate, which I could do because I did a PyPy push. So my latest work is in pip install Pipulate, and I just did it to test that it works. So I know that would work, but because I'll probably be pushing pipulate ahead today, I prefer to do it this way, which just loads it out of my pipdev directory, which is the sibling location. And before I execute that, I'll go over here, do another Control-Alt-T, very traditional. My current work that's not web-based goes on screen number 3. And so I'm often working with just screen 1 for my journal, which we put here. Use my macro to start a daily entry, and hello world. My browser-based work on screen 2 and my other work on screen 3 will CD into, let's see, what was I about to do? Oh yeah, pipdev. And inside pipdev, there's a directory called pipulate. This has to do with the Python packaging process. It's nice to have a directory by the name of your package inside of your release directory. So instead of pipulate/pipulate, I do pipdev just to remind myself it's where I do development work, pipdev/pipulate. And inside there, you'll find this file, which is the initialization file. It's one of those Python idiosyncrasies. So Python has some idiosyncrasies, but it has a lot that just comes very naturally, that is exactly the way you expect. So to get so much the way you expect in Python, there's a few things that are really not the way you expect. And these double underlined things, which are internals, are one of those things. So this gets run every time this package is imported. And so you can take advantage of that to essentially put the entire package in that. So if I were to vim init, there's some different terminology. It would bring us here, and I need an underscore here. I erased an underscore once, not that it really matters. And if we scroll down a bit, you would see the work I put in recently. This persist work here was some of my first streaming, to have a real quick way to get stuff pickled onto the drive. This is the user agents that will be cycling through. I probably don't even need that import out there now that that's internal in pipulate. So iter tools go away. I guess I leave some of the code here. No, I'll leave it as for example's sake, because people are more likely to investigate it in these repos that I'll leave available than they are inside of pipulate, which also is available, but it's quite buried once it reaches pipulate, except API-wise, then it's highly accessible. So this is going to be, I believe, a new file. We don't want SERP scrape anymore. We're advancing the project. File, new notebook, Python 3. And immediately when you do that, you know what, I'll just add a new tab here. CG Python SEO and git status. As soon as you add that new notebook, you'll see there is a new untracked untitled.ipynb in that directory. It knows right away. It also knows the modifications that we made to the SERP scrape notebook. So these are the things where, start using Git, start working Git into your everyday, process, and don't do anything that's not in a GitHub repo. It's just crazy to not have it at least backed up one way. In my case, it's probably 2 or 3 ways after Microsoft OneDrive kicks in and everything. But at any rate, I'll change that name. It's still SERP, but we're refining. We're refining the SERP scraping process, and we're just picking up from the last notebook. It's going to be my new work, so it will go in tab 1. I'm going to be picking up the bare minimum necessary to do a SERP scraping project. And I believe the API, when last we left off, was this is what it takes to do a SERP scraping project. So we only really have to import manipulate, which I will again do from here, reminding you that it's the same thing as doing it as just import manipulate. But I do it this way. It probably won't challenge me. It probably still has my authentication from the last time, but it will say congratulations, printed out twice because of the re-import. But manipulate does so much of the work these days that is tedious, time-consuming, and really the steep hurdles that foil, stymie most people in this kind of work and keep them from becoming technical. So the trick is to get over the things that really you shouldn't have to be dealing with all the time and get down to the stuff just with the language that you really wish to use. So this creates, let's see, I'll call it SERP1, manipulate.SERP. I'll look for Levinix again. I'll call that cache Levinix.pickle. And so there we have it. Those are the search results for Levinix. And it has also created, that's pulled off the hard drive. No, it's not. No, it's not. That's just held in memory right now. SERP1, that was an actually executed search result. And we have the entire requests object here, plus the first page of SERP results. So what we're going to do, normally at this point, we would use the other part of, this is really good. So that just means it's automatically cached. So if I were to pull that again later after a kernel restart, like let's say right now, kernel restart and clear output, one would think you'd have to execute the SERP again against Google, and one would be wrong because of the original work we did in making everything cached using pickling. So if I were to skip this line, normally there would be no value in SERP1. It's just not defined because I didn't execute that. But now I can say SERP1 is equal to manipulate persists because it is persisting. Levinix.pkl. And so now, without executing this line here, which hits Google for a search result, I now have that back in memory. And that was all my work from Friday, really. And say we wanted to see SERP2 against, I guess, let's say the name of my project. The API should be easy enough so that you can just type it again. The Ruby people are all about do it once. Once you type something once, you should never type it again in your entire life. And they're sometimes quite religious about it. I am not that way. I am like, if you created the API correctly, then you should be more than happy to type the API portion of it again. It's not exactly the same, you see. So now I have SERP2 in memory. And if I were to just type SERP2 on its own line, you'd see it formatted like the way it is there. And so Levinix and manipulate are now stored on, not really stored on the hard drive. SERP2 equals manipulate persists. Oh, well, first I want to make it persist. That would just be manipulate.persist. The SERP2 object with the name. Oh, it already does persist. Yeah, they do. They already are there. I don't have to write it. That's part of executing the SERPs that I build in, that I will always put the pickled object there. So I could load it back out of memory if I wanted to. But again, I can kernel, restart, and clear output. I can't emphasize how important it is that first step here in doing Python for SEO work, and remember that's what we're doing. Python for SEO. We did persistence, we did SERP scraping, and now we're just using that persistent scraped SERP in preparing for the next step. But this would be SERP2 equals populate.persists, populate.pkl, SERP2. And there again is our populate response. Now this is just top 10 or however much happens to be on the first page of results, which you could always check by going to SERP2. And we don't want the first object because that is the request object. We want the second object, which is just the list. And then we can do a length of that and see how many items are in there. 6. So there were 6 natural search items on the first page of search results for the word populate. And I could always do Control Shift New for a incognito, type populate. And we take a look here and we can verify that as far as natural search results, there's not many because lots of other stuff fills up and takes its place. So that's 1, 2, 3, 4, 5, 6. Yep, for there's images, so it's pretty much confirmed. Now, one of the interesting things here is that this one here is someone else's repo in GitHub for one of their forked branches of one of my older versions of Populate, where I had a whole server architecture that used, a server that was part of the Populate, architecture, so that it could, it was a hosting app that used bookmarks and everything. And people were enamored with it, and I loved developing it. However, Jupyter Notebook came along and really changed everything. So here I am in Jupyter Notebook, turning Populate into just sort of a Swiss Army knife of different things. Without much further ado, what we want to do is add a capability to Populate, add a capability to the SERP scraping here. So let's get rid of a lot of this. I don't have to keep everything as examples, but I will be creating I won't need to reload it off the drive because almost all the work I'm doing is going to be re-executing the query. So I'll be very careful, but what we need to do is we need to add a num parameter. And I could just say here 100. Now there's a whole position-based parameter, named parameters or arguments and everything that is, a discussion that should be had right now. But if I wanted to try to give a parameter of 100 right now, it would create an error because the SERP function takes from 1 to 2 positional arguments, but 3 were given. See, That's the third argument. Argument 1, argument 2, argument 3. So we need to put support for the third argument, and now you will see why this re-importing of libraries occurs here. Now, these are named arguments from this point. I could always go file name equals, and that would work just as well. And in fact, when you do that, they become less order dependent. You can put them out of order and it would still execute correctly, but as you'll notice, still it's broken, although I would have to re-import it to, really prove that. This is the re-import right there. Still it's broken because I didn't add the support for the third parameter yet. So I go like this, and I go num equals, and by default, it's going to be, I'll just say, I'm tempted to say 10, but I don't want to pass that as an argument. Well, you know what, I will. I'm going to put 10 in there. And now, when the query is constructed, this is Q equals the keyword. Now, if I turn this into a tuple, keyword, comma, num. Now, this will be always passing the number parameter now. So you're kind of tipping your hand, whoops, a little bit to Google that you're not a completely natural human searcher, because the num parameter is not normally passed on the query string, but we are going to do so. So it's num equals, sorry I keep jumping around, but those are just live streaming things, because you see my mistakes and all. Num equals %s, so that means convert into a string what gets passed in over here. I see I got it backwards, so I'll do delete word, paste, and this stuff is weird to see people editing even with mouse and keyboard. So even though it looks a little bit weird in Vim, it's no harder than struggling. I keep making that point. I'm trying to convince myself of that fact. But sometimes you struggle in Vim just like you struggle other places. But you're relying on the muscle memory in your hand to just make sure you keyboard around and do it all correctly. So now I'm feeding 2 parameters instead of 1. It's an optional parameter. If it's not given, it'll result in 10. Now I'm going to take a look again at this one that resulted in 6 results coming back before I feed it the 100. Now, first of all, I do have to re-import, and since I'm going to re-import every time, let's forget this one here. Let's make this part of this code block. Get rid of that. Look how much cleaner it becomes to look at. And now each time I run this, it re-imports the library and executes the SERP. I'll probably put a print above it here. But before I do that, I now can at least look at SERP item 1 and the length of it. See if by feeding the num equals 10, whether I get a 6 still. I get 7, it's 1 more. So there's a certain kind of inconsistency. You can't really expect Google to tell you to do for you what you ask it to do. So num equals 100. This is the moment of truth. Now, you do have to be aware, it's very possible to trigger off the CAPTCHA warning, which is no big deal when you're working on your own like this. You just solve the CAPTCHA in another tab and keep working. When you're on a big network with a lot of people, it's sometimes a bigger issue because they might get the CAPTCHA. But at any rate, see, there's 97. And so for the term pipulate, want to see all the search results? This is going to be much like that, but I'm going to start paring it down so that it's easier to look at. So it is a list. You can tell it's a list by the square bracket on the outside, top and bottom. You're going to get those square brackets, top and bottom, so that it is a list of, and each line in the list is a tuple, open parenthesis, close parenthesis. The tuple, now why isn't it a list of lists? Why is it a list of tuples? Because it's more polite to the memory of your computer to have tuples inside a list than it is to have lists inside a list. Lists are dynamic. They can have different number of members. Tuples are more static. Truth is, they're more dynamic than Python advertises them, but in many cases, they behave much more like static elements. So you know you're going to have 2 items in each item of the list, and you know that they're not going to be change one set. So not going to change, no number of items. Those are your indicators that you're going to want to use tuples. So let's say we wanted to, print. This is the traditional way to do it. Print. Well, now it would be for item in this. You know what? I'll do that down on this next line so that you have the one above it as an example. For item in print. Let's first just print the item. Okay, so it's going to be much like what you see above, but it won't have the square brackets at the top and bottom because I'm not just showing a representation of the object using Jupyter Notebook's built-in formatting. I am showing each individual member of the collection without showing the container token of the collection itself. So if I wanted to just show the first item in the tuple, the URLs, I would put a 0 in here. There's just the URLs, and of course you could click them and visit any of these. And if I were to want to see just the titles, go like that. So already I have support for a number parameter in pipulate, and this was a key goal for today. It's almost mission accomplished with live streaming here. There are other methods to get a lot of search results on your keyword, stepping through the results, page 1, page 2, page 3, all the way up through 10, putting your pages together into one larger object. But you know what? Occam's razor, man. The easiest solution is often the best. You just don't want to do this that often. This SERP2 object is more valuable than ever because these, num equals 100 things you don't want to re-execute against Google all the time. So pipulate.persist. We just drop SERP2, and I would drop it onto the drive as pipulate.pkl. And if I were to kernel restart and clear output, now I've got to be careful now because you remember I put the query on the same line as the import, so we'll edit out these 2 guys. Just import pipulate again. And then go down to here and say SERP2 equals pipulate.persists. Pipulate.pkl SERP2. same exact object as before. And so we have now just added a num equals argument to stipulate. And that's a good place to end the stream, but after doing the commits and stuff. So I do :sh. You don't need multiple tabs to do a git commit, all files with a message, added num equals num argument to SERP function. Git push. So it's up in GitHub that way. People following my code with Git clones will get that. They can always do a Git pull. But for those people following PyPy, then setup.py, oh, I have to cd up one. I can just do vim /setup.py. I'll have to cd up one anyway. So I'll just make this version 3.51. Quit. cd ... release. Now, pretty soon anyone joining me over PyPy with pip install pipulate will get the exact same experience as what I demonstrated here. And remember how I did a :sh to drop into a shell? That means if I do an exit here, I'm exactly in Vim back where I was, where I added that argument. So I'll keep that window open, double check my work here. You know what? We have a new file inside of the repo, which I'm doing here. Git status, git add SERP refine, git commit, adding. So I'm going to be doing something else real soon with a crawl, but okay, that we won't talk about that yet. This is just adding num argument. Adding notebook from adding num argument. Git push. And then that's pretty much it. You know, that's in GitHub updated. You don't need those notebooks when you're doing pip install. And that's pretty much it. I feel pretty good about that stream. Hello world. I just added a num argument, parentheses parameter. Talk more about the difference between arguments and parameters on the pipulate.serp function method for the object-oriented purists out there. I'll talk much more on nomenclature, object-orientedness, methods, functions, properties, callable functions, and all that in future videos. But darn, is this mission accomplished, man. What's most broken? The lack of a num function to do significant SERP crawls when I need it. Speaking of crawls, coming up next, crawling with Python with no crawl packages or libraries if you wish, because it's better that way. You know, for my purposes. In other words, no scrapey or other. I mean, you know, if you're outside the Python world, what most people think of is oh, what is it? I forget, but it's the crawling software that people use all the time in SEO to do crawls of sites. There's cloud-based ones. There's local desktop installs. As soon as technical SEO, the game started being upped. What technical SEO, as Google was changing, people had to start doing sites crawls to get lots of data about a site. And these are some of the most powerful, useful, misunderstood, difficult to control, overkill tools out there. And I'm going to be doing this in the most lightweight, and appropriate to usage way I know how. So that's what's coming up next. Falling with Python. Python. Okay, that's enough. Thanks for joining me. Hope to see you again soon on my stream. And don't forget to follow.